From McCain Auditorium on the campus of Kansas State University, the K-State Radio Network presents an address by the Administrator of the National Aeronautics and Space Administration, retired Admiral Richard Truly. Truly will be delivering the 86th lecture in the series of Landon lectures on public issues here at Kansas State University. As I mentioned, Truly is a retired Vice Admiral in the Navy. He was appointed the NASA Administrator last year. To the stage now, and KSU President, Dr. John Weefeld.
Good morning and welcome to the 86th Landon Lecture on Public Issues. We are very privileged to have as our speaker this morning Admiral Richard H. Truly, the NASA Administrator. Before I introduce our speaker, let me introduce to you other members of the platform party. On my left, Dr. Wayne Nafziger, Professor of Economics and President of the Kansas State Faculty Senate. Next to him, Todd Heitschmidt, a graduate student in agricultural economics and president of the Kansas State University student body. On my right, Edward Seaton, chairman of the Landon Patrons and owner and publisher of the Manhattan Mercury. And then next to him, Dr. Charles Reagan, chairman of the Landon Lecture Series and my executive assistant. Admiral Truly is the 8th administrator of NASA, accepting this position after retiring from the U.S. Navy as a Vice Admiral. The Admiral is the first astronaut to head the nation's civilian space agency. Prior to his appointment as administrator, Admiral Truly served as NASA's Associate Administrator for Space Flight. In this position, he led the painstaking rebuilding of the Space Shuttle program that we all remember so well. Before this, Admiral Truly served as the first commander of the Naval Space Command. Mr. Truly began his brilliant career of over 30 years in the U.S. Navy in 1959 upon his graduation from Georgia Tech with a bachelor's degree in aeronautical engineering. Following flight school, he was designated a naval aviator in 1960. From 1963 to 65, he was a student and then instructor at the U.S. Air Force Aerospace Research Pilot School, Edwards Air Force Base, California. In 1965, Truly became one of the first military astronauts selected to the Air Force's Manned Orbiting Laboratory Program in L.A., California, and transferred to NASA as an astronaut in August of 1969. Admiral Truly has served as part of the crew of the Space Shuttles Enterprise, Columbia, and the Challenger. Admiral Truly has been the recipient of several awards, including the Presidential Citizens Medal, the NASA Distinguished Service Medal, the NASA Outstanding Leadership Medal, the NASA Exceptional Service Medal, and the NASA Space Flight Medal, just to name a few. Ladies and gentlemen, please welcome Admiral Richard H. Truly. Thank you very much. Thank you. Nice to have you here. Thank you.
Thank you very much for that kind invitation and good morning. NASA people don't get the opportunity, frankly, to visit the heartland of America very often because virtually all of our research and operations centers are located on the Atlantic or the Gulf or the Pacific coast of this great nation. So I'm especially honored to be here this morning and to become a part of this renowned Alf Landon lecture series. Foreign visitors often remark that they didn't understand America until they saw the magnitude of the nation's heartland. The Great Plains, the rich farmland, the towering cities rising across the broad rivers of the center of our country. Then the reason for the optimism associated with American character when they do see this part of the country becomes clear. Optimism is not the only thing rooted here. You find wisdom too, especially here in Kansas. And I can personally vouch for this. Standing here as the administrator of NASA and having suffered through a summer of shuttle fuel leaks, the inheritance of a nearsighted space telescope, a budget battle that left us $6 billion short in the space station program for the next 5 years, I can assure you that your forefathers were realists when they decided that the Kansas State motto should be, "To the stars through difficulties." I knew at least one Kansan who lived by this motto. He was my old Space Shuttle flying buddy, Joe Henry Engel from Chapman, Kansas. Joe Henry and I flew both the Space Shuttle Enterprise several times and the Space Shuttle Columbia together. And he never failed to let me know that he was as good as he was because he hailed from, and I quote him because I've heard it 1,000 times, he was from Chapman, by God, Kansas, buckle of the wheat belt. NASA has other links with this great state. Some are especially strong, like the memory of Dwight Eisenhower, whom you commemorate so eloquently with the museum in Abilene. It was Ike's role to be president when the Soviet Union launched Sputnik and presented the first serious challenge to America's technological preeminence. Ike was urged to respond with an intense program lodged in the agency that already was in the forefront of the dangerous U.S.-Soviet competition, the Department of Defense. But Ike feared creation of a massive, single-minded, centrally directed bureaucracy, an American technical bureaucracy. So instead, he created a highly visible civilian space agency. My space agency, your space agency, NASA. In his vision, it would reflect traditional American values of individual creativity, diversity, elevation of the human spirit, and especially openness. NASA's other important link to Kansas is between our decades-long aeronautics research program and your aircraft manufacturing industry with famous names like Boeing and Cessna and Beech and Lear. Because of the fascination with space exploration, a lot of people forget that the first A in NASA stands for Aeronautics, and a 75-year-old flight research program that has been and still is unsurpassed in the world. If you visit the aircraft manufacturers in Wichita today, you'll find their products loaded with technology developed by NASA. Technology that makes aircraft stronger, safer, faster, and more economical. When you really think about it, it is really astounding to consider what has happened since the Wright brothers first flew on December the 17th, 1903. In 87 years, a mere instant in the long history of intelligent beings, we have progressed from the sands of Kitty Hawk to the dusty mountains and the deserts of the moon. From Robert Goddard's 4-second rocket flight to the passage of the Pioneers and the Voyagers beyond the planets of our solar system and into the void of deep space. How, against such an extended human history, could these great events happen so quickly? And why here in America? Why did the human race fly first here? Why were Americans the first and still the only humans to walk on another body in space? Why is it today, around the globe still, that technological achievement is measured against American standards? I think two factors have distinguished America from the other nations of the world. First, America was and still is the land of opportunity. From the beginning, it opened its gates to all people regardless of race, religion, or origin. Today, that door remains open, and they still come, bringing their skills, their hopes, their willingness, and their determination. The other is America's emphasis on freedom. Freedom of religion, freedom of speech, freedom of the press, freedom of movement, freedom to choose the government, freedom to make economic decisions, freedom to set your own goals and pursue your own life, and freedom to reach for the stars. This has been a climate in which new ideas and new capabilities could flourish, and flourish they have. And they have flourished most in this wonderful field of activity, flight, that has filled the lives and aspirations of every one of us. Today I want to talk most about the beginning of the exploration of space, about the moment in history that you and I share, a period that's now only 33 years old. It commenced on October the 4th, 1957, when the Soviet Union showed us all that mankind could break the chains of gravity and place a man-made object into orbit around our Earth. This single event has had a profound effect on humanity. It has led to a revolution in global communication made possible by satellites. A revolution in all aspects of electronics, including information processing, made possible by the miniaturization required and driven by space programs. A revolution in military intelligence gathering that has helped keep the peace for our generation. A revolution in new products and new processes. In fact, more than 30,000 new products to simplify life, to do away with onerous tasks, to save time, and to improve the quality of our living. A revolution in our knowledge of our planet and our sense of responsibility to preserve those conditions that allow life on this precious place to flourish. Perhaps the greatest argument ever in behalf of the environment and against pollution and nuclear war was the first spacecraft photograph of Earth in its entirety. A beautiful, inviting, but fragile blue ball suspended very much alone in the harsh black void of space. And then the revolution in our knowledge of our solar system and of the universe beyond, raising profound questions about mankind's role that today still have to be settled. Our ancestors looked up into the night sky and saw a majestic canopy of changeless and wonderful stars. Then came the telescope, and the night sky suddenly was transformed. As time moved towards our generation, instruments of great power began to unveil the immensity and the complexity of this universe, but always constrained to that small window surrounding the visible wavelengths that could find its way through the Earth's atmosphere. But finally, in our own lifetime, and as a matter of fact in our own generation, spaceflight has enabled astronomers to place their instruments above the obscuring atmosphere and see all the messages, all the radiations from all the sources at all the wavelengths that the universe was sending us. This explosion of technical capability has changed our view of the universe radically. Today we know that it is enormously large and violently dynamic. It is populated by vast structures like galactic strings and walls. It contains mysterious objects of unimaginable energy like quasars and black holes. In our own local neighborhood, the solar system, you and I, have visited every planet in this solar system save Pluto, and we have been to some several times, and we have discovered extraordinary things. We have found atmospheres reminiscent of the early Earth. We found evidence of water. We found active volcanoes, and even the possibility of ancient oceans. We've encountered enormously deep canyons, mountains that dwarf those here on Earth, and unimaginably turbulent skies with storms that last for centuries, like Jupiter's great red spot that was first seen 400 years ago through an Earth telescope. We have found oxygen locked in the rocks of the moon, which someday may be used as propellant. We have found helium-3 in those same rocks, which some people believe in some future decade could help produce energy on Earth through clean fusion. We have succeeded in placing a lander on the planet Mars to analyze the soil. Our orbiters there have found evidence of ample frozen subsurface water on that planet. And we have found more, so much more, in our initial journey through our solar system. But we have not found what we really hope to find: evidence of life. In 30 years of robotic and human exploration and observation, we have failed to disclose life anywhere except here on this planet Earth. The message we have gathered from this failure is keep looking and look harder. I'd like to tell you where we stand today. On January the 28th, 1986, America's space program was rocketing along. We had been flying the world's only returnable space vehicle, the Space Shuttle, for almost 5 years. The ability to routinely send large crews into Earth orbit gave us a boost to the life sciences. We had embarked on a new science of microgravity materials processing. We were well along on the design of America's first permanent home in orbit, Space Station Freedom. Our robotic explorers were ranging the solar system. A commercial space sector was coming into being, and we had even begun working on the technologies needed for people to return to the moon and travel to the planet Mars. And then on that day in 1986, we had a tragic and terrible accident. And it was not just Challenger. In the few months that surrounded the Challenger accident, there were 2 Titan 34Ds, a Delta, an Atlas, a French Ariane, and a Soviet Proton lost. Here at home, that combination forced us to stop and focus all of our attentions on what we had done wrong and to correct those problems. In the case of Space Shuttle, it took about 2.5 years, but we did it, and we resumed human space flight in this country on September the 28th, 1988. That flight has opened the door to an intense, unprecedented period of activity in all areas of space science and space exploration. Magellan is already mapping the planet Venus. Galileo is on its long and circuitous journey to Jupiter, and Ulysses is moving out of the solar system's ecliptic plane to examine the poles of the sun. Cassini will orbit Saturn and send a probe to its moon Titan in 1996. And just as Joe Henry Ingle and I flew close formation in our flying days a few years ago, the Comet Rendezvous asteroid flyby mission will fly formation with a comet for several years beginning in the year 2000. Orbiters also will be sent to the moon and to Mars to pave the way for human exploration. We are learning much about climates, about atmospheres, topology, geology, and chemistry, especially the kind that might produce life. In astrophysics, we will orbit 4 great observatories to look at the universe across the electromagnetic spectrum, from infrared through gamma rays, with unprecedented resolution and clarity. The first of these observatories, despite what you hear, the Hubble Space Telescope, is already returning superb science. The Gamma Ray Observatory will fly next spring in April, and the Advanced X-ray Facility and the Space Infrared Telescope Facility will follow. Earlier this year, a little satellite called the Cosmic Background Explorer confirmed predictions based on the Big Bang theory of creation of the universe and produced the first clear image of the center of the Milky Way galaxy. And after conquering early mechanical problems that you just read about this past week, the Astro 1 astronauts and the ground team of scientists were elated with the data that they got, some of which is unique in the history of astronomy. And I was elated just night before last at their safe return. 13 successful space shuttle flights in just 26 months. On the average, for the last 26 months, a safe and successful flight every other month, and I'm proud of that. Our goals in astrophysics are quite ambitious: to uncover the nature of quasars and black holes, to discover places where life might exist, to learn the age and the size of the universe, and to predict its ultimate fate. To do all that I have just described requires us to look out from Earth, but I think it's just as important that we look back. In the 1990s, virtually every country in the world will participate in an effort to understand the Earth's global systems and how they work together. The purpose is to give this and future generations the data required to make accurate and timely decisions to prevent further deterioration of our only home and its environment. This effort is called Mission to Planet Earth. A key American contribution will be the Earth Observing System, a comprehensive series of polar orbiting spacecraft able to view the Earth with a variety of instruments simultaneously. Other spacefaring nations will launch satellites too. Another area of interest is in microgravity sciences. Today, right now, there are 16 NASA centers for the commercial development of space, and they're developing ideas to test in microgravity. 52 universities, including Kansas State, are associated with these centers, plus 175 corporations, including many of America's largest. Key to major progress in this area will be the International Space Station Freedom. It will provide large, well-equipped laboratories without the requirement of returning to Earth every few days. The United States, Canada, the European Space Agency, and Japan will build the space station and furnish these laboratories. But the chief reason that we need space station freedom is to learn how the human body and psyche react to long-duration exposure to zero-G, to microgravity. This is key for that future day, and it will come, when the first human lifts off from a launch pad on that inevitable journey to the planet Mars. As you perhaps have detected, a great deal of our 1990s activities will help set the stage for expansion beyond Earth orbit. President Bush announced this as a national goal in a talk on July 20th, 1989, the 20th anniversary of man's first landing on the moon. In that speech, the President called for completion of space station freedom, then a return to the moon, this time to stay, and then exploration of the planet Mars. Human exploration, preceded by robots, will expand the frontiers of scientific knowledge by employing our most powerful computer, the human mind. Only the human mind and brain can make giant leaps of inference. Maybe computers will do that someday. What I've outlined for you this morning obviously is a most ambitious program. Is it the correct space program for America today? Last August, we decided to step back and ask that question again. With support from the top, from the President and the Vice President, who is Chairman of the National Space Council, I appointed a committee of distinguished, experienced citizens to review the nation's space program and NASA and make recommendations. The group has completed its work, and last Monday its chairman, Norm Augustine, the chairman of Martin Marietta, explained its findings to the press. And I'm happy to report that the committee concluded, and I quote, "America does want an energetic, affordable, and successful space program." I'm also glad to report that the program that this independent group recommended coincides very closely with the programs and the policies that NASA has been pursuing. The committee stated that the United States should maintain a civil space program balanced among 5 elements: space science, mission to planet Earth, a mission from planet Earth, first to the space station, then to the moon, and then to Mars with robots and human beings, a greatly expanded technology development program, and creation of a more robust space transportation system. While NASA has taken some lumps in the last 2 days from a media which seems to have turned NASA bashing into a journalistic art, the committee said of us, and I quote again, "The committee believes that NASA, and only NASA, realistically possesses the essential critical mass of knowledge and expertise upon which this nation's civil space program can be sustained. And the task at hand is, therefore, for NASA to focus on making the self-improvements that gird this responsibility. In other words, making an excellent organization more excellent. NASA will study this report in great detail and will live up to its responsibilities. We hope that other organizations with responsibility for the nation's space program will too." Earlier in this talk, I noted how technology invented to get us into space and out to the planets had been transformed by private enterprise into products and processes, and even whole industries that have changed the way we live. To live permanently in space and on bodies other than the Earth will require a vast amount of additional technology. If the past is prologue, this means that another new wave of products and processes will have an impact on us and our children, and it will be just as great as the impact of microelectronics, computers, communication satellites, and all the rest. Some of the new technologies that we are or will be working on to return to the moon and go into the planet Mars are artificial intelligence, virtual reality, advanced robotics, telepresence and teleoperation, ultra-high strength and high-temperature resistant materials, supercomputers, wireless power transmission, and many others. And I expect that we will experience over the next quarter century of space exploration a major breakthrough that we cannot envision today. Certainly Benjamin Franklin did not envision New York City lit up at night or a digitized society when he first flew a kite in a thunderstorm. And it's doubtful that those who first dissected the atom realized that they had found a new and practical energy source. Expanding our presence into space sets the stage for discovery, perhaps in medicine or in materials or energy or transportation. Now we are lofting telescopes and other instruments of enormous power. They will radically change our view of time and space again. The continuing exploration of space will involve greater international cooperation. Rising costs and political imperatives are bound to drive today's spacefaring nations to cooperate. But the real driver, I think, is the increasing belief that not individual nations, but the human race should undertake the expansion off this planet. Finally, there's the question of life elsewhere. Is there any? In a sense, everything NASA does seeks to answer that one question. We know one place in the vast universe where life exists. We have identified its vital components. We know the factors that allow it here to flourish. As we search the solar system with our instruments and our robots and scan the sky beyond with our telescopes, we look for similar components and factors. What if, after acquiring the ability to search, and having searched for decades or even centuries, we find nothing? Then we will have gained a sobering bit of knowledge. We may come to see ourselves as sole keepers of the flame with a terrible responsibility to never let it go out. But suppose some night a NASA receiver hears the dim remnants of a faraway signal that is unmistakably not random and therefore of intelligent origin. How would the human race react? Certainly fear by some, certainly elation by others, and undoubtedly a heightened sense of our humanity. Perhaps a new view of certain conflicts, which suddenly would seem quite trivial. But one thing's for sure, it would change the world, and the human race would be off on another great adventure, a learning adventure. We would become eavesdroppers on an unprecedented scale, listening intently to and trying to decode the conversations of another civilization. We would want to know what they were like physically and intellectually, how they get their energy, how they combat disease, how and where they travel, what natural resources they have, how they use them, what traditions they hold dear, and gods, if any, that they hold sacred. This certainly would happen because, if nothing else, mankind is curious. It has been all of its existence. More than anything else, curiosity impelled folks over the next hill, across the next river, across the oceans, and then the continents, and then into the atmosphere, and now into space. Soon it will drive us on to the next planet, and then to its moons, and then on to the next, and the next, and the next. Your invitation here for me to deliver the Alfred M. Landon lecture today has been a wonderful honor that I will not forget. And the opportunity for me to return to the center of this land I love has been a personal pleasure of immense proportions. Thank you very much.
Oh, you do? Yeah, it's unbelievable. Do you want to ask some questions? Sure. Admiral, truly thank you very, very much for a fascinating and excellent presentation here this morning. But we do have some time for questions. As you know, we have microphones on either side, so I'm sure the Admiral would be very pleased to answer any questions that you might have. So do you want to move to the sides and come down?
Yes, sir.
My name is Chuck Thompson. I'm a professor in the psychology department here. I was very interested in your comments about international cooperation and agree with your analysis in that regard. What interests me is the following. Given our remarkable change in relationship with the Soviet Union, and given that they have, I'm sure, at least the second best program in the world, is there any possibility now, do you think, that they will join in that international effort?
The Soviets are very interested in cooperation with the United States on many areas, including the space program. I visited Moscow about a month ago for a week to see their space program. I had been there once before in 1975. We're lucky in one sense because across the years of the Cold War, one area of international dialogue that we have kept open has been the exchange of scientific information about space research, and so we even at a very low level, and many times that's only been an exchange of data, at least we know each other. And I agree with your comment, incidentally, about the quality of their program. It's very different than ours, but it's very deep. They have doggedly pursued it. I think that there will be areas of potential cooperation. I would say that I believe that areas of cooperation should start carefully and be on a very step-by-step basis rather than jump into something extremely difficult like a mission to Mars or something of that magnitude. But I believe that there is room for better relations between us.
Good morning. I'm Vincent Needham from the Physics Department. The Augustine Committee is scheduled to reconvene in 6 months to monitor NASA's compliance with its suggestions. What in particular are you and your program managers doing in that relatively short span of time to meet their suggestions?
Norm, you're right, and I've invited Norm to come back in about 6 months. As a matter of fact, this coming weekend, I've planned a management retreat of our NASA senior leadership, not only in Washington but around the country, to meet with most of the members of Norm's of the Augustine Committee, so that I've met a great deal with them, but I'd like our senior people to understand what underlies some of their recommendations. I'm going to set out immediately to tease each recommendation out of their report. We need some of them have quite large or small fiscal ramifications. Some will require action by the Congress, some are not. Some will require action by the White House. But for those that NASA can do, I intend to do what everybody does that's managing an organization, and that is make a list of the recommendations, try to understand each one. Those that we think we should and can accept immediately, to go ahead and do that and set them in motion. Some will take years, I think, to change. Some have to do with the way we do our business. And as I said, even though the immediate press reports I've been very disappointed in, because they have misunderstood some of the things the committee said, and secondly, they tend to dwell on the negatives. That's natural, I guess, at least in my business. And but I see a lot of good work behind us, and I think by the time 6 months goes by, when Norm comes back at my invitation, that he'll see we've made a lot of progress. I would also point out that we have a standing advisory committee that is quite renowned, that will be working with the people in NASA on a day-to-day basis, and a couple of members of the Augustine Committee are on our advisory committee. So we've got a great deal of overlap. They've made some very constructive suggestions. Some will be easy to do, some will be awfully difficult. Yes?
My name's Heather Young, and I've been following the space program forever. I want to be an astronaut. But I was wondering, how will the proposal for the redesign of Space Station Freedom affect the Japanese and the ESA's part in Space Station Freedom?
The international partners are a part of the reassessment. And and our goal is to meet all of our, I believe very strongly that when the United States makes international commitments, that we ought to live up to them, or we'll become an unreliable partner in the eyes of others around the world. Nevertheless, when the Congress cuts out $551 million out of this year's budget in that program, and $6 billion in the next 5 years, our partners quite recognize that we are going to have to go into a reassessment. They are a party to it, and I believe that when we come out, we will have met our goal of meeting our commitments to them. And if we absolutely cannot, they will understand why, and it will be a cooperative venture.
And I was also wondering, with Mission to Earth, will you be doing more with space debris, trying to track it, and what other things might you be doing to take care of the problem of space debris?
We are working to understand the debris environment quite quite hard, but it's not a part of the Mission to Planet Earth. It's a part of another portion of our program. Mission to Planet Earth is a series of satellites that looks back at the Earth itself, whereas the orbital debris understanding is one that's very crucial. And we're not only working to understand the debris environment better, but also trying to get some international dialogue so that other nations will take greater care in designing spacecraft so that they will not be, for example, exploded in orbit, or which creates an unbelievable cloud of debris. So we're working hard on that front, but it is a real problem, and I hope you do become an astronaut someday. If you haven't given up that chore, you'll love it. Yes.
Admiral, truly, my name is Vicki Froney. I'm a graduate student in the physics department. Ever since the early days of Mercury, when I was about the same size as some of the audience members in the balcony, I have thought that it would be a major milestone in the history of manned space travel when a manned space flight does not make it into the newspapers, when manned space flight is routine enough. And also during the days of Mercury, I seem to remember hearing, perhaps on a news broadcast during one of the flights, that a goal of manned spaceflight was to be able to launch a 65-year-old poet into orbit. Could I have your comments, please?
Well, I don't think, first of all, I don't think that spaceflight, particularly taking men and women into the orbit, is ever going to get to the point where it doesn't get into the newspapers. I can tell you, for a guy who runs an agency that spends less than 1% of the federal budget, we get on the front page of the newspaper every time we fly. And I think the reason is because we conduct ourselves in an open manner, and when we lay it on the line, we lay it on the line. And that grasps the public attention. We're like the little girl. When she's good, she's very, very good, and when she's bad, she's horrid. And that tweaks the public interest. As to the second part of your question, I think today, at least, until we get our feet more firmly on the ground or in space, as you may want to put it, that I believe we'll stick to professional astronauts and leave the driving to them, at least for the moment, although I was a great supporter of our civilian and space program, and having seen the Earth, I would love to provide the capability to a teacher, to a poet, to an author, to experience the kinds of things that test pilots and people like that have done. But it's a risky business. Don't ever let anybody kid you. And the only way to really not have that risk is to not fly. And I don't think that's in our blood. Yes, sir. Yes.
Sir, as far as funding for the program of NASA itself, how are we standing as far as expenditures, and is the President working enough with you to get the funds to enhance the program itself?
For years, the space program was depressed in funding, but I can tell you that we've worked very hard on it, and in these last 5 years since the Challenger accident, we have almost doubled the NASA budget. In this past year, even though like all government administrators, I am quick to point out the money we didn't get, I must tell you that the President went into the Congress this past year with a NASA budget that was a higher percentage increase than any other major federal agency, and we came out with almost a 14% increase, which represents about an 8.5% increase in real dollars, even after taking account of inflation. And we have been on this increasing ramp now for the last 4 years, and so even though I will continue to bemoan the fact when we don't get what we think we need for our programs, I think there's plenty of agencies of the government that would die to have our record.
Okay, my name's Jessica. I'm Kristen. We're from Lee School, and we were wondering if you always wanted to be a pilot and with NASA.
I did think about being a pilot when I was your age, and when I was in school. I didn't realize I would ever have the opportunity until I was in college at Georgia Tech, and I went to Georgia Tech on a Navy scholarship, and one day it occurred to me that I could try to go to flight school, and for that I would pay 1 year of obligation to the Navy other than what I already owed them. And at that time I never dreamed I'd stay in the Navy. And so I filled out my application and got accepted and went to become a Navy fighter pilot and then a test pilot and astronaut, but I never knew any of that would happen. But when you grow up, if you have those ambitions, I would sure recommend you try. It's a wonderful occupation. They even pay you to do it.
I think we've got time for about 2 more. Here's a student right over here.
My
Yes.
name is Holly,
And I'm Audrey.
and we're from Lee School, and we were wondering if you knew any of the people or were very close to the people that died on the Challenger disaster.
Yes, I knew them all, and a couple of them were some of the two of them were two of the closest friends that I had. I was very close to them. One was Mike Smith, who I flew the first night launch and night landing of the Space Shuttle, and Mike had worked with me to develop the instrumentation and the lighting that allowed that flight to happen, and I knew him very well. The other that I knew closest was Judy Resnick, who was also killed on the same flight, but all the members of the crew of the NASA crew I had worked with when I had been in the astronaut office. There were 2 people on the crew that I didn't know very well. One was Krista McAuliffe, who was the teacher, and the other was a fellow by the name of Greg Jarvis, who was a payload specialist, but I was very close to them.
Okay, I'm Jim, and he's Willie. And we had a 2-part question. One is, we'd like to know if you personally think we should develop the National Aerospace Plane and basically give up the shuttle, and he's going to ask the other one.
Okay. Well, let me answer that first. The answer is very much yes and very much no. We should develop the National Aerospace Plane. It is exactly the kind of a research project that NASA was designed to do, but it's a very hard technological achievement and would not become operation if we're able to do it for another couple of decades. As to Space Shuttle, the Space Shuttle is going to be the backbone of this country's capability to fly men and women in space for well over the next decade. And incidentally, that's exactly what the Augustine Committee concluded and what they wrote in their report. They do believe that we ought to also develop a heavy lift launch vehicle to take some of the pressure off the shuttle. But we must, the Space Shuttle is far and away the most reliable, most capable, and the best space vehicle that any nation owns, and we should not walk away from it. How about the other question?
In your speech, you stated something that we had resources on the moon. Can you tell us which ones they are and if we can actually extract them from there?
I'm sorry. The resources on the moon. Thank you. The easiest resource that we think we definitely could get would be to get oxygen out of the rocks. In other words, if we went to the moon and with a habitat to, say, take astronomers there, they would need oxygen to breathe. And one of the things that we probably would do would be set up a factory, if you will, a plant on the surface of the moon to get oxygen out of the rocks so that we could use that oxygen to sustain life of the people that were there, so that we would not have to pay the cost of hauling oxygen from the Earth to the moon in order to sustain the habitat.
That's it. Thank you very much. Wasn't that a great lecture? Thank you. Thanks for coming. Thank you very much.
Sure. Well, let me just tell you, I'm delighted to be here this morning. I've looked forward to the trip. I get the opportunity to go around the country and speak to a lot of people, but coming here to this lecture series is something I've been looking forward to, and thank y'all for taking the time to come here this morning. And you heard what I said in there, so. Yeah.
I had a question right off the bat.
Sure.
You were talking about the planet, us all being one as a world. Is it frustrating for you to watch the money and the energy being poured into a potential conflict? What's going on in the Persian Gulf?
Oh, it's awful. I've seen that part of the world from orbit, when you fly in space, you really do have you get a very physical and real personal feeling about how fragile the Earth is. For example, the Earth is about 8,000 miles in diameter. If you go home tonight and find a globe and imagine, and just look at it, and you can hardly. And imagine it's 8,000 miles in diameter. You can hardly hold your fingers together enough to measure the amount of atmosphere that separates the people that live on that Earth from nothing. And to fly and see, and to imagine, what we're doing to ourselves in a lot of different ways, both politically and environmentally, is something that means a lot to people who have flown. We have not laid out a timetable for the Moon or Mars program. The Space Station Freedom program will start being constructed in 1995, just 5 years from now, and it will take a few years to actually construct it to its final configuration, where we would have 8 people essentially living permanently aboard the station, although they would be swapped out, of course. But in the Moon and Mars exploration programs, which would be very expensive, of course, the right way to approach those is to lay in place a real investment in technologies. And as in all technologies, the technologies would be useful here on Earth for many other things, but we need to be able to do such a program, not in the expensive way that we know how to do it now, but to develop new engines and new capabilities so that we can do it cheaper in the future. Yes, sir.
Admiral, sometimes you hear the criticism of space program as money that could be better spent in social services programs and upgrading the third world nations situation. How do you answer that, sir?
Well, I believe that the nation should invest a good portion of its dear capital to help the homeless, to help people who are in need, to solve the problems that we have in our cities, and et cetera. But frankly, if we waited to discover and to explore until we had all the problems solved in our local communities, in our cities, we would never discover or explore. And for a nation as rich as ours, to spend about 1% of those dollars in a program that is so good and so forward-looking for the future of the country, I think is money well spent. But you certainly could not spend that money. You could choose to not invest in the future in programs like the space program and new technologies and apply those monies to today's problems. But if history is prologue, each nation that has done that has cut off its future. If Portugal stopped exploring, China decided for itself that it would cease, it would turn inward instead of outward, and I just don't think that is the course that I would recommend to my fellow citizens to pursue.
In other words, what you're saying is some of these biological probed in space are well worth the money and are really contributing to the
Well, first of all,
welfare of the people? Is that it?
yes, but first of all, every dollar the space program spends is spent here. It's spent here on technology. It's spent in this country or in our partners with engineers and scientists, the kinds of jobs that create communities and create other wealth. The bakers and the candlestick makers form communities around scientists and engineers. And now, you could take the argument that as an example, that instead of spending money on space, I'll just go spend money directly on some other need that we have now. But that's not the kind of people that we have been, and since the money we spend on space is so small compared to our national dollar, I think that that's one of the reasons that even though this debate goes on, that frankly over the years the public and the Congress have been major supporters of NASA and the space program and in aeronautics. I think we're a major contributor to our country's well-being, even though our goals are to learn more about the universe.
How does it make you feel to see the young people's enthusiasm about the space program? They were just
Oh, I love it. I love it. I never. I think one of the most exciting things NASA does is talk to and help educate young people. I think we can play an important role in math and science education in this country for a very simple reason, and that is that our programs, airplanes, spaceships, astronauts, planets, get to kids. And young people just love us. They love what we do. To them it's exciting. They don't appreciate, frankly, the blood and the sweat and the hours and but they do appreciate exploring or looking around the block or learning something. And that's what the space program's all about. And I think that we capture a lot of them. We ought to capture a lot more. We can always do better. But I think a lot of our country's education problems can be contributed to, not solved, but can be contributed to in a very real way by our education programs. And that's why I talk about it as much as I do. And we spend a good bit of money in curriculum on the airplane today. Riding from Washington to here, I read a 3rd through 8th grade curriculum that had been developed in space flight in a cooperative program between USA Today and NASA. And we do that kind of stuff all the time. But I love talking to him. All the good questions, all the new questions I've ever heard, almost without fail, have always come from a kid. They just see things in simple ways and in ways that other people have thought about a lot, but they just think of questions and ask them in ways that I've never heard before, and I love it.
You mentioned that all the flights in the last 26 months have gone up and returned safely.
Yes.
Do you feel like we're at the point now where everything is okay now at NASA and the people you gain their confidence again in the public?
I think the shuttle program is running today better than it's ever run before. We could get rid of shuttle and get another spaceship that would take men and women into Earth, and it would also be risky. And if you flew it long enough, sooner or later you'd have an accident. And if we keep flying long enough, we're going to have other accidents. It may not be like Challenger. It may be a nose wheel failure on a landing or something else. But statistically, if you fly long enough, you're going to have mishaps. And that's true of all forms of transportation that I know of. But frankly, I think shuttle program is running better today than it ever has. It's a very, very capable system. And I think we're managing risk in the program about as well as we know how to do. And what more can you ask than that?
How devastating to your program would it be if you did have another fatal mishap, some of the challenges at this point?
I don't know. I would hope over the years, first of all, we don't have another accident. But I would hope that our country can come to realize, and that's why I stand up and say it's a risky business, because people need to appreciate that with risk comes mishaps sooner or later. That doesn't mean the next shuttle flight cannot be made to be flown safely. But I would, it might be very politically risky for my career, but that really doesn't matter. I would hope that the public would be able to ride through another mishap, because sooner or later they're going to have to. May not be 1990 anything. It may be 2005. I don't know when it'll be. But we've had accidents before, and sooner or later it'll happen again. But in the flying business, there's only one way to prevent that, and that's stay in the hangar. Any others?
One more.
Yeah, go right ahead. Sure.
I'm on a roll today. How hard was it to go from being an astronaut to an administrator? Is that frustrating to you professionally?
Well, I felt like I'd had a marvelous and lucky flying career. I've flown about almost 8,000 hours, most of it single place jet fighter type airplanes. Flown off the carrier, I'm one of the few people that have flown 3 times on the 747 and never once inside, on top in the orbiter. After I flew my last shuttle flight, I got the family together and we took a vote, and it was unanimous that it was time to move on and do something else. I've enjoyed the jobs I've had since then. I love running NASA. It's a great job. But is it frustrating? You're damn right it is. There's a lot of politics involved, the thing that frustrates me the most is undue criticism to the people in NASA. It doesn't bother me personally, but to see people that are doing something for the country that is so important and they're doing it so well, to see them when they do make mistakes, and they will. But to see them when they make mistakes be made to look like people who don't know what they're doing, that's fundamentally a very dangerous thing for this society to do, and that does bother me. Well, thank you all. I appreciate it.